My name is Neil Stringfellow. I am the Executive Director of iVEC. iVEC is a joint venture of 4 universities, public universities in Western Australia, and the CSIRO. And we are in charge of the Pawsey Centre, for the management and operations of the Pawsey Centre, and for our community, for our partners, we are responsible for providing services in supercomputing, in data, storage, analytics and management, and in visualization. The Pawsey Centre was created as a project about the beginning of 2009 in order to provide an extra value in terms of having high performance computing, supercomputing available to scientists in Western Australia and in Australia as a whole. Our funding coming from the Western Australian government for operations, and particularly for a lot of our staffing, means we have a focus on our Western Australian partners. In particular, there is a focus on a couple of areas: geosciences, nationally significant and significant at the state level, and radio astronomy. Radio astronomy in particular because of Australia's bidding for the Square Kilometre Array.
So the Square Kilometre Array, or the SKA, is going to be the world's largest scientific facility. It's a radio telescope, it's dishes and receivers spread out over hundreds of kilometres, and each one of those receivers receives radio waves from the universe, turns those radio waves into digital signals, and eventually from those digital signals we make images of the sky in the radio part of the spectrum. It's the most sensitive radio astronomy facility ever made. It's about 10,000 times more sensitive and better at probing the universe than any facility we've ever had before.
So the Pawsey project is an $80 million project, Commonwealth funding. iVEC was able to demonstrate to the Commonwealth government that it was going to be perfectly capable of managing and operating a world-class facility, and it was therefore chosen, along with the fact that there were certain focuses on geosciences and radio astronomy that were important to the Commonwealth, and therefore Pawsey Centre was granted to iVEC for its management of operation. And the Pawsey Centre building is of the order of $30 to $35 million of investment. A wonderful investment at that, including some very innovative technologies in terms of cooling and in terms of its green credentials.
CSIRO is the nation's premier science agency. The CSI Geothermal Project has developed a groundwater cooling solution for the Pawsey Centre supercomputer. This system uses ambient temperature water from an aquifer 150 metres below the surface. The water is pumped to the surface and run past a heat exchanger to extract heat from a supercomputer before it is returned to the aquifer, slightly warmer with no net water loss. The water savings alone are estimated at 38.5 million litres a year.
A key aspect of making that data valuable is making it available, and to that end we have built a dedicated iVEC network which provides a 10 gigabit per second link between the 5 partners and their various facilities. We also link into the Australian Academic Research Network, ARNet, and this allows collaborators and scientists from, for example, eastern states, but also from the international community to be able to quickly access the data sets that we host and use them in their own research.
So the most traditional elements that you will find in a supercomputing centre are themselves the supercomputers. And in this particular centre we will have 2 major supercomputers with 2 different purposes. One of them is tailored very much to the needs of one of the Square Kilometre Array Pathfinder projects, and that would just be taking the large volumes of data that are coming down from the Murchison Radio Observatory and processing them in real time so that there are products that astronomers can look at and analyse. The much larger machine will be available for general science with a particular focus on the geosciences, but with also many other areas of science that are of interest to us, from fluid dynamics to modelling of bread.
So for example, a researcher may wish to create a fluid dynamics simulation of a vehicle such as a car. This simulation would typically start in the I/O cell, where they would use our data analysis engines to create the background mesh on which their simulation would run. Once the mesh is created, it would be transferred across the iVEC network to the supercomputer, to Magnus in the supercomputing cell. And on Magnus, the researcher would run that computational fluid dynamics simulation using the capabilities of the petascale facility. Once the simulation had finished, The large output data sets that would typically be produced by such a simulation would be transferred back to the I/O cell, where the raw data could be translated into more meaningful results, such as a visualization of the vehicle and the flow over it, or other measurements of pressure, velocity, and so on. Once the researcher had completed that post-processing analysis, they would typically archive their results onto our tape store, where the data would sit available for reuse and for other researchers to see what they had done with their simulation.
In a couple of decades, we will have harvested all of our energy and mineral resources that is readily available at the surface. We're now looking in this National Research Science Precinct for the future of geosciences, for future energy and mineral resources. Currently, we are on the PAWSI stage 1, and we're using the facilities for mainly big data assimilation visualization and for sustainability research.
PAWSI effectively becomes part of the SKA, part of the telescope. We have to have high-performance computing plugged right into the data flow from the telescope because there's so much data flowing, we have to process it in real time. We can't afford to stop and collect it and store it and think about it later. Supercomputing has to be plugged right into the very fabric of the telescope itself. The PAWSI is the machine which is going to catch the data and turn the data into this interesting new view, this amazing new view of the universe. Without PAWSI, none of this is going to be possible. And it's somewhat humbling to think that PAWSI, as it stands today, is only 1% of the machine that's going to be there in probably 10 to 15 years from now to deal with the whole SKAs.